Hi everybody. Before this, talk about our full adder digital circuits by PSPICE and also LT-SPICE. For this one, I'm going to, since we talk about logic gate, state, AND gate and OR gate. In this case, somebody already know about it. You can create digital logic gate using diodes in case that you don't have AND gate, OR gate, or you don't have IC. You have tons of your diodes. So we're going to take a look how to use diode to create digital logic gate. In this case, going to be your AND gate and OR gate. But in practical, we not really use this one for digital logic gate because they're going to be many output and inputs. But this is just show you how to use the diodes to create digital logic gates, and I believe that there are many people know about it already. But we will get deep inside how this thing work. Okay, so if you take a look at the truth table of OR gate and AND gate, you already know that you have like two inputs, A and B. Your output for the OR gate, I use the symbol A plus B. And total logic combinations of two inputs is going to have like 4 of them. And you know that for the OR gate, whenever either one have the input to be 1, as will give you the output to be 1 for the OR gate. And for the AND gate is seem to be work opposite around, right? Whenever your input either or B, have a logic status to be 0, that will give you your output of the AND gate to be 0. Okay, so let's go through the PSPICE then. How to connect to a diode to create digital OR gate. So first, let's get the diode. That's going to be D1N. You can pick any of them. So in this case, let's get D1N 4002. And I also need their ground, right? AG and D. And I also need the input as their VDC, either 0 or 5 volt. Okay, let's rotate this around. Control R. And then let's put this one as the 5 volt. Attributes 5, and this one also 5. Right, so let's use this one as their input, and this needs to connect to ground. So I make the wire connection, and then connect input to the diode, P-type diode here, and then also this one going to be your output. So let's label as the Vout. Okay, so let's take a look at this one. How it works? Let's make assumption. When the P type, or on the left of your diode here, the voltage higher than the right, or the N type. That means that your diode is going to be on, turn on. And if you want to take a look what is the voltage you need to turn on the diode, you simply can do some testing. So I Control C, I Control V, just show the diode, and you also need your R. You can put any number of your resistance. So let's make it 10. Just to see the voltage drop across the diode when it's on. You also connect this one, make the complete circuit to view. Okay, let's see. I'll set this one as the diode gate testing. Let's do our simulation here. Alright, show you the current. So you can see that the voltage drop across the diodes you can calculate by minus 5 from 4.1. So this gives you about 0.9, right? Is the diode in case you want to see the V on, you can go to model. You go to edit instant model. So your V on is simply I'm not sure it's show here or not. Not really. Okay, doesn't matter. So 5 minus 4.1, that's about 0.94. So that means that the voltage drop across the diode, and the diode requires at least 0.94 for a diode to turn on. And if you take a look at your digital diode gate, you can see that when the input, let's say this is the input A and B, both are what? 1, logic 1, or oops, I want just to label the input here to be input A, and this one, label this one to be input B. When both their input has the logic status to be 1, the output will also be 1, which is 5-4, right? You have 5-4 here. If you analyze the circuit, this means when you have the 5-4 here, and then the voltage, this one it will turn on the diode, so that means the diode is on. So VL will follow your input, which is in this case is 5-4, or logic 1. So 1-1 gives you Vout. Seem to be like both of them connected in parallel or parallel arrangement. So either input A or B is 1. This will give you output as 1. Just like when you connect Christmas light or New Year light in parallel. Okay, so either one, if it doesn't matter if one of your light bulb blow out, is the rest of your light bulb still on. And if you want to test the rest of, you have like 4 logic combination, right? So this means I follow this logic combination as 0, 0, 0, 1, 1, 0, and 1, 1. You want to test your circuit here. So you already have, you want to start from 0, 0, right? Follow the truth table here. 0, 0, 0, 1, 1, 0, and 1, 1. So you want to do 0, 0. So you simply, you short your output. and then this is going to be what, 0 1, right? A becomes 0, so you short this one out. This gives you your input 0 1, and this one is going to be 1 0, so you shorted your input B, and the last one is you left just like that, 1 1. So let's take a look at your output. So you go to simulate. Oops, sorry, is there something wrong here? Oh, okay, no. Well, the problem here, because you were duplicate name here, vout. So let's put this one as the vout 1. And this one going to be a vout. Somehow when you copy that, it doesn't change automatically. You go this one to be vout 2. Get this one to be vout 3. And the last one, vout 4. Okay, that's the re-simulate. Still have problem. Signal being used for different signal. Okay, we still have this one B. Attribute. This is going to be A1. Oh, okay, this is because it is the shorted, so this one A1, this B1 turn to be your A1 because shorted, and this one to be A2. But you already know about it, right? The basic idea how to use diode to create or digital logic gate. This one to be A3, the attribute, and this one is become a B4. Oops, B3, sorry. And this one to be A4. Almost done. B attribute to be B4. Okay, you re-simulate. Still have some error, huh? See what the error complete. Now what's wrong? Let's go to the output file. Examine output. Error voltage source and or inductor loop in 4v2 may be break a loop by adding a series of resistance. Okay, some problem. So that's why basically they add up our resistor here. So Control GR. To make simple, Control G, A, G, and D. It's easiest to explain, by writing on the paper. But here I just want to show you also by using PSPICE, because give you also voltage and the current flowing through the circuit. That's in practical, not theoretical. Let's put this guy to be what? Attribute to be just 10. Okay. And then let's put this guy. So, get rid of the problem. Control C, Control V. Let's see if it's going to have to be a problem or not. Do analysis, simulate. Still have some error. I don't understand. Submit output. Voltage source are inductor before V2. Okay, so this specify V2. Where's V2? Where's my V2? Oh, this is V2, just right here. What's wrong? You show heater. Just have some problem. Better I take this one out. Take V2 out. Control W here. Let's connect directly to source. To D2. Go to analysis. Go to simulate. Still have some error. So this guy have problem. You show to examine output. Probably showing the same thing of V5. Where's my V5 here? Control W. Go back to explain this later on, but because we focus on the digital logic gate, still have some error. V6 probably gonna follow. This might be 6. W here. Right. Hopefully your problem solved. Still have error. Let's mean output. Just give you V1. Back to this. This seems to be it's not allowed here for you to short your supply voltage. Okay, now it's working now. Let's take a look at your output. Enable. Okay, in this case you have our input 0, 0. That means give you V out. Just right here. It's very low. That's 0. And for your input 0, 1, we have output to be 4 or digital logic 1. And this also 1, 0. This gives you output to be 1. And for 1, 1, of course, you get the output to be 1. Okay, so this explain how the circuit work, and use the diode as the digital logic gate. Now let's move to let's see here to AND gate. So how you going to do some change stuff. So let's pick up this guy. Control C. I'm going to do the AND gate. The way that they arrange the circuit, you just switch this one back. Just simply Control F. And this guy going to be input A. And we want to create an digital logic gate, followed by this one corresponds to this truth table. Okay. Now just take this guy out. Okay, this is going to be input A, and this is going to be input B, but they going to be a little bit different between the diode digital logic of OR gate and AND gate. But instead you need to connect your diode. Resistor. Okay, so actually just put it this way. Control R to see better. Hook up this one here, and you delete this. Cue this guy. You connect this one. Okay, let's see how you're going to design your like circuit. these ones seem to be going to be your input. You already have F4, eh? So this one going to be your A5. I want to label this one to be A5, and this one going to be your B5 as well. You go to edit, you go to label. This is B5. Click OK. Oops. Alright. Now this one you need to connect your voltage. Okay, so I need the voltage here. Just Control C, Control V, and I rotate around just to supply to this. Control W here. Also you need ground, and Control C, Control V. And this one, of course, to supply 5 volt. So your attributes already have a 5 volt. Now let's see how the sorry diode digital AND gate work. Okay, you take a look at this one. This is the always like have 5 volts, and when you supply sorry, for diode to be turned on, the voltage at this point, or the P type, has to be higher than the N type. So when you have the 5 volt coming in here, this means the voltage here is higher than the voltage here, because somehow you have 5 volt here, right? And of course 5 volt have to drop across 10 ohms resistor. That means you have the voltage here is lower than 5 volt. So that means this diode is going to be off, like same as the diode at this point has to be off. So your output has to follow when this one is off. The voltage at this point have to follow the voltage, the supply voltage here. So that means this one going to have the logic 1, and this one have also logic 1, but they are in parallel anywhere. Now in the case of you have the input to be low or 0, that means the voltage at this point is going to be higher than the voltage at this point. So that means your diode is going to be on. So when it's on, your negative, your 0, or your grounded, is going to connect directly to the ground and pass that 0 to the output. So your output is going to be 0 whenever they have 0 here. Whenever a diode is on, that means your output is going to be on 0. Correct? So that's how it works. You can explain later on, for the case of the logic combination of 0, 0, 0, 1, 1, 0, and 1, 1. Okay? This might seem to be a little bit complicated, but this is going to apply your logic, to analyze, how to create digital logic gate using diodes. And more than that, you can create 3 input OR gate or 4 input logic gate. Simply you can just add up another 2 diodes and do the same connection. You can try by yourself. Here, this one is going to be 4 input OR gate. Okay, I'll see you later on. Okay, bye.